The mockery crackled over the radio from Tokyo. The Americans have landed on Leyte with their primitive tools and crude bamboo engineering. They cannot hope to rebuild what our brave pilots have destroyed. They will be annihilated on the beaches without air cover. That was the Japanese propaganda line in October 1944. Then, the skies answered with a different sound. The thunderous, rolling roar of hundreds of radial engines. The situation was desperate. The U.S. Sixth Army was locked in a grinding fight ashore at Leyte in the Philippines. Their advance was stalling critically because they were out of range of their own fighter cover. Japanese bombers and fighters, operating from intact bases across the archipelago, pounded Allied positions with impunity. General MacArthur's headquarters issued an impossible order: get airfields operational immediately. Conventional engineering assessments suggested it would take months to repair the bomb-cratered Japanese runways and build new ones from the swampy ground. Then the impossible happened. In just 30 days, Allied engineers, using methods and materials their enemies had laughed at as primitive, achieved a logistical miracle. They didn't just patch a single strip. They built, repaired, and made fully operational 23 airfields. Almost overnight, the skies over Leyte filled with the distinctive twin-boom silhouettes of P-38 Lightnings and the rugged frames of P-47 Thunderbolts. Local air superiority was decisively won. This is the story of how the Allies turned a term of mockery, bamboo engineering, into the most devastating, rapid construction doctrine of the Pacific War. To understand why the Japanese laughed, we must look at their deeply held beliefs about industrial warfare and their own engineering superiority. The Japanese confidence was built on a deeply ingrained engineering philosophy: permanence equals strength. Heavily influenced by pre-war German techniques, the Imperial Japanese Army and Navy invested colossal labor and materials into building fixed, reinforced concrete fortifications. This doctrine was physically embodied in the massive underground complexes of Rabaul, the formidable bunkers of Truk, and the intricate steel-reinforced emplacements rising on Iwo Jima. Their technical manuals prescribed rigorous standards for airfield construction: deep crushed coral foundations, steel matting or concrete runways, and extensive drainage systems, all requiring heavy machinery, stable supply lines, and time. This materialist mindset bred profound contempt for Allied methods they observed in earlier campaigns. Japanese officers, in intercepted communications and translated diaries, repeatedly dismissed Allied use of local labor, expedient timber, and pierced steel planking (PSP) as primitive, amateurish, and symptomatic of a lack of industrial rigor and long-term planning. They saw the use of native materials, often mischaracterized as bamboo, as proof of technical inferiority. A captured Japanese intelligence summary from mid-1944, later translated by Addis, perfectly encapsulates this arrogance. The American engineer relies on the native and his jungle vines. He cannot pour proper concrete under our artillery fire. His airfields will always be temporary, fragile, and easily destroyed. Their bamboo engineering is a testament to their weak logistical spine and their inability to fight a sustained technical war. To the Japanese High Command, this was not an adaptive threat. It was a comforting symptom of Allied weakness, confirming their belief that willpower alone, without superior permanent infrastructure, would fail. What Japanese intelligence failed to grasp was that the Allies weren't failing to build like them. They had invented a completely new and far more lethal form of warfare: expeditionary engineering. The Allied challenge was defined by the tyranny of distance. Projecting air power across the world's largest ocean created a brutal equation. Every mile closer to Japan dramatically increased a bomber's payload and a fighter's loiter time. Seizing a coral atoll or a jungle-covered hill was only the first step. That ground was worthless without a functioning airfield, and building one with traditional methods was a logistical nightmare. The numbers were staggering. Transporting the thousands of tons of steel Marston matting, cement, heavy graders, and crushers required to build a single heavy bomber field required dedicating precious cargo space on vulnerable, slow-moving ships across thousands of contested miles. The U.S. Navy Supply Corps tracked every ton, and the tonnage needed for permanent bases was starving the forward movement of troops and ammunition. This created the time versus enemy dilemma. From the moment the first Marine or infantryman hit the beach, the clock started ticking. Japanese counterattacks by air, land, and sea could materialize within hours. A construction timeline of weeks or months, typical for a permanent airfield, was a death sentence. They needed fighter cover yesterday. In the China-Burma-India theater, the problem had a different shape but the same route. The famed hump airlift to China was critically constrained by a lack of advanced airfields. Building these fields in the remote Assam jungle using solely imported materials was agonizingly slow. A frustrated U.S. Army Services of Supply report in 1943 captured the crisis. "We are building cathedrals when we need tents. Our engineering is not matched to the pace of the war." The system was failing under its own weight. The solution wouldn't come from a traditional engineer's manual. It would come from a radical willingness to use whatever worked, wherever they were. The Allied secret was not a single gadget, but a revolutionary doctrine: expeditionary engineering. Its core principle, formalized in U.S. Army field manuals, was the use of local resources. This turned the environment from a hindrance into a toolkit. The most potent local resource was bamboo. U.S. Army Engineer Research and Development Laboratory tests in 1943 confirmed what Asian builders knew for centuries. Bamboo possessed a tensile strength-to-weight ratio rivaling steel. It was lightweight, abundant, and grew rapidly. Engineers used it for pile foundations, drainage culverts, scaffolding, corduroy road matting, and even as feedstock for gas generator units. The second pillar was a labor force multiplier of staggering scale. In China, the nationalist government mobilized a civilian bamboo army of hundreds of thousands of workers. In the Pacific, Navy Seabees and Army engineers organized local islanders into massive work gangs. A 500-man engineer battalion could effectively command a 5,000-strong workforce, achieving earth-moving and material-hauling feats impossible for machinery alone. The third pillar was the technological linchpin that made it all tactical: pierced steel planking, PSP, also called Marston mat. These interlocking, perforated steel panels, patented in 1941, were the miracle surface. They could be shipped compactly and laid directly over a prepared base, often a layer of compacted coral, gravel, or bamboo matting, by a small crew in a matter of hours. The holes provided drainage and reduced weight, while the interlocking design created a continuous, load-bearing surface for the heaviest fighters and transports. This was not a makeshift compromise. It was a sophisticated, layered system. Bamboo and mass labor solved the foundational bulk work, instantly moving thousands of cubic yards of earth and creating a stable subbase, decoupled from the Trans-Pacific supply chain. The PSP solved the final, critical problem of creating a hard, fast, all-weather runway surface. Together, they collapsed construction timelines from months to days. It was the killer application of industrial design married to ancient, local material science. Nowhere was this system put to a more brutal test than on the island of Leyte, where a desperate army needed a miracle, and the Japanese were convinced such a miracle was a physical impossibility. The scene on Leyte in late October 1944 was one of chaotic, muddy desperation. The initial landings were successful, but torrential monsoon rains immediately followed, transforming the ground into a bottomless quagmire. Pre-invasion bombing by Halsey's carriers and Kenny's 5th Air Force had effectively cratered the Japanese airfields at Tacloban and Dulag, but had not magically created usable Allied runways. Instead, it left a landscape of water-filled shell holes and debris. Into this morass landed the specialized units tasked with the impossible: the 5,202nd and 5,203rd Engineer Aviation Construction Brigades, alongside attached U.S. Navy Seabee battalions. Their convoys beached amidst ongoing infantry battles, offloading bulldozers, graders, and crates of PSP directly into the mud. They were construction workers arriving on the front line. The Japanese response was immediate and violent. General Tomoyuki Yamashita, commanding the Japanese 35th Army, understood the stakes perfectly. Captured orders state his directive: delay the enemy engineers at all costs. Without airfields, their army is blind and helpless on the ground. Japanese artillery observers on the commanding highlands like Hill 522 adjusted fire onto the obvious airfield sites. Mortar barges walked across work areas. Snipers and nighttime infiltrators specifically targeted equipment operators and survey teams. Seabee after-action reports describe engineers working with M1 rifles slung over their backs, taking shifts on perimeter guard duty. Yamashita was confident. He believed the combination of his artillery, the determined resistance of his infantry, and the relentless monsoon rains would make a mockery of Allied bamboo engineering. In his diary, he calculated he had weeks to reinforce Leyte before the Allies could achieve local air dominance. It was a race between Japanese reinforcements and American engineering. On a flooded, shell-pocked field designated Tacloban Airfield, the first bulldozer, its yellow paint caked in mud, fired up its diesel engine. The 30-day clock started ticking. The construction of Tacloban Airfield was not a project. It was a high-speed, industrialized battle fought with bulldozer blades and sledgehammers. It operated with assembly line precision under fire. Survey teams, protected by infantry squads, staked out the runway alignment while sniper rounds snapped overhead. Bulldozers and draglines, their operators shielded by makeshift armor plate, then carved and leveled the soggy ground. Simultaneously, organized bamboo brigades of Filipino laborers cut, hauled, and wove dense mats of bamboo, laying them for drainage and sub-base stabilization. Gravel trains of trucks, running a shuttle from nearby pits, dumped loads of crushed coral. Finally, the PSP teams moved in, locking the 10-foot steel mats together with connecting pins, rolling forward a durable, all-weather surface like a giant metallic carpet. Improvisation was constant. Fuel drums filled with sand became instant culverts. Coconut logs were lashed together for aircraft revetments. Captured bags of Japanese cement were used for critical abutments. The system absorbed punishment. A Seabee officer's memoir recounts a direct artillery hit on a fresh PSP section. The crew simply hooked the mangled mats, filled the hole, and laid new ones, losing only 20 minutes. To capture Japanese soldiers watching, this rapid repair was a psychological shock, undermining their belief in permanent, vulnerable infrastructure. The climax came on October 27, 1944. As the last PSP panel was locked into place at Tacloban, a C-47 Skitran loaded with critical ammunition and medical supplies was already circling overhead, waiting for the all-clear. The radio crackled to life. Tacloban is open for business. The transport descended, its wheels touching down smoothly on the steel matting, rolling out without a hitch. A cheer erupted from the muddy perimeter. The dam had broken. Within hours, the first P-38 Lightnings of the 49th Fighter Group landed, refueled, and were airborne on combat air patrol. Then came the bombers. The engineering battle was won. The opening of Tacloban was just the beginning. It was the vital proof of concept. Now, the same frantic, replicated process ignited across Leyte like a virus of construction spreading faster than Japanese artillery could adjust. From the central drama of Tacloban, the miracle multiplied. The Japanese command structure descended into paralysis and shock. Ultra-decrypts of their coded signals reveal a cascading crisis. A November 5th message from the 35th Army headquarters complained of new airfields appearing daily at impossible rates. Orders were frantically issued to shift artillery to target new coordinates, only for another operational strip to be reported elsewhere before the guns could be repositioned. Their intelligence picture, and thus their entire defensive plan, was rendered obsolete in real time. The tactical consequence was absolute air dominance. Within a week of Tacloban opening, 5th Air Force sortie rates from Leyte soared by over 300%. With local fields now swarming with P-38s and P-47s, Japanese resupply convoys attempting the run to Ormoc Bay were annihilated from the air. Simultaneously, Allied bombers now based on Leyte began a relentless pounding of the Japanese air bases on Luzon, destroying aircraft on the ground and cratering their runways, extending the zone of Allied air control northward. The psychological impact was profound. Post-war interrogations of Japanese staff officers reveal a fundamental disillusionment. One stated, "We had planned for a battle of attrition on the ground. We were prepared to fight for months in the mountains. We were not prepared to lose the sky in 30 days. Your engineers. They were a combat force we did not understand." The term bamboo engineering vanished from propaganda broadcasts. In its place, a grim new reality was documented in their own unit codes: Kuchu Tishur, air denial. The terrain they had chosen for a protracted defense had been weaponized against them by men wielding bamboo, local labor, and interlocking steel. The victory at Leyte was immediate, but the impact of this engineering doctrine would echo all the way to the shores of Japan itself. The success at Leyte did more than win a battle. It compressed the entire timeline of the Pacific War. The rapid establishment of air dominance allowed General MacArthur to accelerate the invasion of Luzon by weeks, a shift documented in revised Joint Chiefs of Staff planning schedules. The Leyte model became the unbreakable blueprint for the final assault on Japan. This model was replicated with ruthless efficiency. At Iwo Jima, even as the brutal infantry battle for Mount Suribachi raged, U.S. Navy Seabees and Army engineers had central field operational enough for the first emergency landing of a crippled B-29 just 3 days after the initial landing. At Okinawa, the same formula of massed engineering battalions and organized local labor built and repaired airfields that hosted hundreds of fighters and medium bombers for the invasion of Japan itself. The ultimate strategic payoff was the B-29 campaign. The airfields built using this expedient doctrine on Saipan, Tinian, Guam, and Iwo Jima became the indispensable launch pads for the superfortresses that burned out Japanese cities and strangled its industry. The steel mats laid over Pacific coral, the drainage solved by bamboo, the labor provided by thousands of organized workers. This was the logistical foundation upon which the strategic air war rested. A direct line can be drawn from the bamboo-ranished fields of Leyte to the firebombing of Tokyo. A 1945 U.S. Strategic Bombing Survey report concluded with definitive clarity. The rapid construction of forward air bases was the single greatest logistical achievement of the Pacific War, without which the bombardment of Japan would have been impossible. The humble bamboo, and the doctrine of its use, was a silent, indispensable partner in that apocalyptic achievement. This was more than a tactical workaround. It represented a fundamental shift in the philosophy of modern warfare. The historical significance of bamboo engineering transcends World War II. It marked the birth of modern rapid airfield construction, RAC, as a cornerstone of U.S. and NATO power projection. The systemic fusion of local materials, bamboo, coral, organized mass labor, and modular technology, PSP, created a reproducible doctrine for generating air power from any patch of ground, anywhere, at unprecedented speed. This became a critical Cold War imperative, leading to dedicated U.S. Air Force Red Horse squadrons and refined NATO standards for building airfields under threat. The technological lineage is direct. The pierced steel planking, PSP, of 1944 evolved into the aluminum AM2 matting used throughout Vietnam and the Gulf War. The concept of laying a metallic carpet over an expedient base remained unchanged. Only the alloy improved. Operations like Harvest Bear in Saudi Arabia, 1990, where a 10,000-foot strategic airfield was built in weeks, are direct operational descendants of the Leyte model, applying the same principles of prepositioned materials and rapid assembly. Culturally, it forged an enduring legacy. The U.S. Navy Seabee can-do ethos and the Army engineers' creed of adaptability were hardened in the mud of Tacloban and the black sand of Iwo Jima. The ability to fight and build simultaneously became a defining, unmatched characteristic of American military engineering, blending combat arms skill with construction expertise. The Japanese high command mocked a process they fundamentally did not comprehend. They saw only the primitive material, the bamboo, and dismissed it. They failed to perceive the sophisticated, industrialized system. The doctrine of expedient resource utilization, married to modular steel technology, and multiplied by organized labor. In the end, bamboo engineering didn't just build 23 airfields in 30 days. It built a new paradigm for modern warfare. It proved that the ability to rapidly generate infrastructure is itself a weapon of strategic decisive effect, one that renders static, permanent defenses, the very kind Japan invested its soul in, obsolete. So what is the final, undeniable lesson from this story of mud, bamboo, and steel? The story of bamboo engineering delivers a timeless, documented lesson from total war. Adaptability and systemic thinking will always defeat rigid doctrine and material arrogance. The Allies won the construction war and thus the air war because they mastered the system of building, not just the act. They created a formula that turned every environment into a resource. The ultimate irony is stark. The Japanese Empire invested its finite resources, time, and strategic mindset into building immutable fortresses of concrete and steel. The Allies invested in a formula of flexibility, modular technology, local materials, and organized labor. In the vast theater of the Pacific, the formula proved infinitely stronger than the fortress. It could move, scale, and accelerate. The fortress could only sit and await its inevitable siege. The scale of the achievement is staggering. By August 1945, U.S. Army and Navy engineers had constructed or repaired over 600 major airfields and advanced bases across the Pacific and Asia. Countless more fighter strips and emergency fields dotted the map. Hundreds of these began as sketches in the mud, built by men whose greatest tool was an unshakable willingness to use whatever the land provided, married to industrial ingenuity. This relentless innovation wasn't limited to the ground. Subscribe and hit the notification bell, because in our next video, we return to where this adaptability first took flight. The Cactus Air Force on Guadalcanal. This is the story of how shot-up planes were resurrected with parts from wrecks, how mechanics worked under Japanese shellfire, and how a handful of pilots held an island with pure tenacity. It's the story of engineering in the sky. History documents. Mock your enemy's tools at your peril. He may be building your defeat with them.